When working with a right triangle, there are some terms to remember. The side opposite the right angle is the longest, and it's called the hypotenuse. The other two are called the legs. So let's say that we have this value is 5, this value is 6, and we want to find the hypotenuse, which I'll call x. We can use Pythagorean's theorem, which says that the sum of the legs squared is equal to the hypotenuse squared. 5 squared is 25, 6 squared is 36, and that sum is 61. When we square root both sides, we get 7.81. Let's make this 5.0 and 6.0. Now, because these each have 2 sig figs, we can give our answer the same number of sig figs as the givens. But there's more to a triangle that we can calculate. Let's say we want to find this angle theta. Theta is something that appears in our trig functions. So tangent, sine, and cosine are the trig functions. And theta appears in parentheses after the function. We can use SOHCAHTOA to identify what each trig function yields. Tangent, that's opposite over adjacent. So tangent would be opposite the angle is 5, and adjacent the angle is 6. Sine uses opposite O over hypotenuse H. So opposite again is 5, and the hypotenuse is 7.8. Cosine of the angle theta would be adjacent over hypotenuse, so 6 over 7.8. By the way, this letter is a Greek letter, which in English we call theta. It's kind of like an O with a line through it. Alright, so now that we have these 3 trig functions, how can we actually solve for the angle which we're using theta to describe? So the way we solve, if you take this tangent and you imagine dividing both sides by tangent, or multiplying by the inverse, the tangents would cancel out, and on the right side we would have the inverse tan of 5/6. Inverse tan is a function on your calculator. There's a button for inverse tan. So you hit second tan 5/6, and that gives you your final angle of 39.8 degrees. And because we're going to round to 2 sig figs, just like the givens have, this will become 40 point degrees. The decimal is there to show that both of these digits are significant. If you found the inverse sine of 5/7.8 or the inverse cosine of 6/7.8, you would get the exact same value of the angle theta, 40 point degrees. So what have we learned? We've learned that you can find the hypotenuse from the 2 legs using the Pythagorean theorem, and you can find the angle, which we're calling theta, using the inverse tangent of opposite over adjacent. Let's take another right triangle. We're going to call this adjacent. This is opposite, which means that our angle is this one here. And I'm going to give that angle a value. Let's say the angle is 37 degrees, and the hypotenuse is 6.4. How would we find opposite and adjacent? Again, we can use our trig functions. Sine, cosine, and tangent. We have hypotenuse, so we know we're going to be focusing on these two because they both include one of the givens, which is the hypotenuse. So how do we find the opposite leg in particular? Well, we have opposite as the unknown, hypotenuse is given, and we know the sine because we know the angle. So we use sine. In the parentheses, we put the value of the angle itself, 37 degrees. The opposite leg is our unknown, that's what we seek. This is the unknown. So we leave it as opposite. And the hypotenuse, that's this long leg. So that's this long side, I should say. So that's 6.4. We cross multiply both sides by 6.4. And what do we get? Opposite equals 6.4 sine 37. Make sure you're in degrees mode for this whole process. And the answer is 3.85, which rounds to 3.9. We can do the exact same thing to find the adjacent leg. The adjacent leg appears right here. That's our unknown. We know hypotenuse, and we know the cosine value because we have the angle itself. So we write down cosine equals adjacent over hypotenuse. We can plug in values. In place of the parentheses, we put the angle itself, 37 degrees. Adjacent, that's our unknown, so we leave it as adjace. And the hypotenuse is 6.4. You cross multiply both sides by 6.4, and the answer is 5.1.